For activity 1.11, part E, we're going to find the derivative of the function 1 over t. So first thing to do is name it f prime of t equals, and we're going to be doing a limit. And yes, we do want to write this every time. It's a very important part of the process. Now we set up our difference quotient. 1 over t plus h minus 1 over t all over h. As a reminder, our difference quotient is f of t plus h minus capital F of t for this case all over h. Now what makes this the derivative again is the limit as h goes to 0. This gives us our f prime of t. So now we're in charge of doing algebra on this thing. Well, when we have a rational expression like this, first thing we're going to want to do is find a common denominator. So limit as h goes to 0, and the common denominator is going to be t plus h times t. So this first term is going to become t over t times t plus h. The second term, we have to multiply by t plus h. It's going to become t plus h over t times t plus h. Still all over h. That gave us our common denominator. Now we can write that over a single denominator. Limit as h goes to 0. T minus, and now it's the quantity t plus h. So I'm going to use parentheses. It's going to be very important going forward, because a lot of times what happens is the t gets subtracted, but the h does not. So that's a common mistake. T times t plus h. We could multiply that out, but there's no point because of the way this thing is going to simplify, because eventually I'm going to take the limit as h goes to 0. Now, look at what's going to happen on top. So I got limit as h approaches 0. I'm going to distribute my negative, t minus h all over t times t plus h all over h. Some people like to write it as times 1 over h, and that's fine. You'll get the same answer. Here's our big thing that happens. We get the t's to cancel. Okay? Now remember, this is like being h over 1. So dividing by a fraction, we multiply by the reciprocal. So we got limit as h goes to 0, of minus h over t times t plus h times the reciprocal, because we're dividing by a fraction, 1 over h. Now, this is important because there's where our h's cancel and we get a minus 1. Notice now we can take the limit as h goes to 0 by direct substitution, because it will not cause a 0 in the denominator. So I can plug a 0 in for that h. So I get negative 1 over t times t plus 0. Notice I'm no longer writing the limit notation because I've taken the limit by plugging that 0 in for h. This is going to give me minus 1 over t squared for our derivative.